Hello everyone, lecture 4, rank of matrix. In this lecture, we will discuss rank of a matrix, how to find the rank of matrix by the method of minor order, Echelon form of a matrix and normal form of a matrix. Now start with rank of a matrix. So the matrix has a rank R if there are R independent rows or column, and it is denoted by the rank of matrix denoted by row A. So there are three methods to find the rank, basically by using the minor order, or convert the matrix into Echelon form, or by converting the matrix into normal form. So by this method we can find the rank of a matrix. And what's the rank? Rank is just an independent rows or says column vector in the matrix. Now the rank by the minor order. So first we have to know the what is minor order of a matrix. So minor is what is an determinant of a square matrix formed by deleting one row or one column from a large square matrix. So we take an example. Suppose we have a matrix A whose order is 3 cross 4. So we have to write the minor order of that matrix. This matrix is not a square, but we can write the minor order of that matrix. Every minor is what is a square, means, so the order is what 3 cross 3. So we write the minor order, means the order, first we write the order 3 cross 3 minor, that is minor order of A is, if we delete the first last column, so we get a matrix A1. So this is what, this is a minor order of 3 for matrix A. Similarly, if we delete the second column, and we obtain a matrix A2, and if we delete the second column, so we get a matrix A3. So in similar manner we can also delete the first column and remain as it is, so we get another matrix. So these are what, these are the minor order of 3 cross 3. In similar way, if we want to write the minor order of that A1 matrix, so we can write the lower minor order is what, 3 cross 3 is what, 2 cross 2. So we can write this is a minor order A11, A12, A21, A22. So this is a minor order, and we can also write this is a minor order, these are the minor orders. So in that way we can write the minor order of a matrix, of a given matrix. Here we have to note the matrix says the rank of a matrix A is said to be R if it possesses the following two properties. The first one, there is at least one non-zero minor of order R whose determinant is not equal to 0, and if the matrix A contain any minor of order R plus 1, then the determinant of every minor of A of order R plus 1 should be 0. Thus we can say the rank of matrix is what is the largest order of non-zero minor of matrix. So let's take an example to better understand. Find the rank of a matrix. Suppose A, we have a matrix minus 1, 3, 4, minus 7, 3, minus 4. This is an order 3 cross 2. We have 3 rows and 2 columns. So first we have to check the highest minor order of that matrix A, and it can be the minimum of the order 3 and 2, that is 2. So the highest order of minors of A is what, 2, means we have to write 2 cross 2 minus. So it can be, if we delete the last row, so it can be minus 1, 3, 4, 7, the first one. The second one, if we delete the first row, so we write 4 minus 7, 3, 4, and if we delete the last row, first row, sorry, middle row, that is row 2, so we get minus 1, 3, 4, minus 4. So these are some possible minors of order 2. Now we check the determinant of these minors. So we see what all are not equal to 0. The first one is minus 5, second one is 37 minus 5. So what we can say, we say the minor order of order 2, minor of order 2 of for matrix A is not equal to 0. Therefore we can say the rank of a given matrix is what? Is 2. Here we have to note even 1 become non-zero. Any minor order of, we are checking the minor, suppose we check the minor order of 2 and any one of is not equal to 0. So we say the rank is what? Rank is 2. Now take another example to find the rank by minor order. Suppose we have a matrix A and this matrix has a order 3 cross 3. So first we check the highest minor order of that matrix. So the matrix A is a matrix of order 3 cross 3. So minimum of 3 and 3 is what? 3. The highest order of the minor of A is what? Is 3. Means we have a minor order 3 by 3. That is 1 minus 2, 3, 2, 4, minus 6, 5, 1, minus 1. Now the value of that minor or says determinant is what? Is 4, which is not equal to 0. So we can say the rank of that matrix is what? 3. Now if suppose the determinant or say the minor of that matrix of order 3 is equal to 0, then we say the rank of matrix A is what? Is less than 3. In that condition we check the lower order minor, that is 2 cross 2, which may be like this or this or this or this. So in that way, if all that minors of order 2 is 0, then we say the rank of that matrix is less than. If the all minor of 2 cross 2 is 0 all, then we say rank of A is less than 2. If any one of them is not 0 of order 2 cross 2, then we say rank is 2. So in that way we find the rank of the matrix by minor order. But this method is applicable when we apply on 3 by 3, 4 by 4. But if the size of the matrix is bigger, means if we say we have a matrix of order 20, then it is too difficult to find the determinant of that matrix. So we use the another methods to finding the ranks. Now we discuss the Echelon form of a matrix. So a matrix A is said to have in row Echelon form if it follow or say if the following property hold. The first one, all rows consisting of only zeros are at bottom and the leading element, that is called the leading element of non-zero row, is always strictly to the right of the leading element of the row above. So the first element or the first row, if we take as a non-zero element and make it 1, that is called the leading element. So these are the leading element, we can say. So how to convert a matrix into Echelon form? So step 1 is start with the first row and search the non-zero element of each row, non-zero element of that row, which is called leading element. That element is called leading element and make it 1 by using the proper row operation. If it is already 1, then it's okay, otherwise you make it 1. So that is called leading element, and by that the help of that element all the entry below make 0. all the entry below the leading element should be 0. So if entry below leading element is not 0, so make it 0 by the help of that leading element. And the process repeated. Come to the second row, search the non-zero, first non-zero element, that is suppose this one, this is already 1. Then by the help of that one, make this 0. And then come to the third row, search the non-zero element, that is 5. Then it make it 1, and below element make it 0 by that element, by that leading element. Now, which of the matrix is in row echelon form? So we have four matrices A, B, C, D. Now we check which one is a row echelon form of a matrix. So the first matrix, that is A matrix. So A matrix A is not row echelon. Why? So because if we remember the definition of the row echelon form of a matrix, so the leading element of non-zero row is always strictly to the right of the leading element of the row above. So here the leading element in the first row, the leading element is this one, but when we come in the second row, the leading element is the first element of row 1. And by the definition, we know the leading element of non-zero rows is always strictly to the right of the leading element of above row. So for that, if we want to make that matrix convert into a row echelon form, so what we do, we just interchange R2 with R1. So the matrix become 1 0 0 1 0 0. Now this is echelon form of matrix. Okay, now come to the second matrix. So is this matrix is a row echelon form or not? So again, matrix B is not row echelon. Why? Because by the definition, some maybe the some writers can be say the it is echelon form, but by the definition, we follow the definition, all the rows consist of only zeros are at the bottom. But in the matrix B, what is happen, the zero row is in middle. So to make that matrix into row echelon form, we just apply the operation R3 interchange with R2. The matrix B become 1 2 0 1 0 0. Now this is echelon form. Okay, now come to the third matrix. So the matrix C is an echelon form of a matrix. So the answer is no, because what's the process? If we search the echelon form of a matrix, first we search the first non-zero element of first row, that is 1, and below all the element is 0. Is it okay? Now come to the second row and the search the non-zero element, that is a leading element. This is the leading element, and below element is should be 0. But the the leading element of second row is 1, but the below element of that element is not 0. So to make that matrix into echelon form, we apply the operation R on R3 minus R2. So the matrix C become 1 2 0 1 0 0. Now this is echelon form. And the last one D. So is it the echelon form of a matrix? So we say yes. This is a echelon form of a matrix because the first element search the first non-zero element in first row, that is 1, and below entry should be 0. Is it? And come to the second row, search the non-zero element, that is the element 1, and below entry is 0. So this is a echelon form of a matrix. So this is a process to search or how to identify the row echelon form of a matrix. Now, now how to find the rank by echelon form? So the rank of a matrix is what? When we convert the matrix into the echelon form, so the rank of the matrix is equal to the number of non-zero rows of a matrix. That is, we can say number of non-zero rows in the matrix after the matrix convert into the echelon form. Obviously simple, the number of non-zero rows in the echelon form of the matrix. Now take an example. Reduce the matrix A to echelon form and hence find its rank. So we have given a matrix A. This matrix is of order 4 cross 4. So first we convert that matrix into echelon form and then we discuss the rank of that matrix. So first when we convert the matrix into echelon form, we have to remember we apply only row operation because we convert that matrix into row echelon form, not column echelon form, because we are discussing only row echelon form. So the first step, search the non-zero element of the first row, which is 1. Non-zero element is 1. If it is not 1, so make it 1. This element is called leading element. And the second property, convert all the entry below the leading element should be 0. So to make these elements 0, we apply a row operation or row transformation. The first operation we use R2 minus R1, and similar time we apply the operation on R3 minus 2 time of R1, and on R4 minus 3 time of R1. So the matrix become first row same because we are applying the operation on R2, R3, R4. The second row 1 minus 1 0, 3 minus 2 1, 2 minus 1 is 1, 2 minus 2 0, 2 minus 1 2 minus 2 time of 1, that is 0, 0 1 0, and on R4 we apply the operation R4 minus 3 time of R1. So 3 minus 3 0, 7 minus 2 time 3 into 2, that is 6, 7 minus 6 is 1, 4 minus 3 is again 1, and 6 minus 2 into 3, that is 6 0. Now then we search the non-zero element of second row, first non-zero element of second row, which is this. So this is a leading element, so make it 1, but this is already 1. This is a what? This is the leading element of second row, and the entry below should be 0. So this element is already 0. So we apply the operation on R4 to make that element 0 by the help of leading element. So we apply the operation R4 minus, apply on R4 minus R2. So the matrix reduce, the first row is same, second row is same, third row is also same because we apply the operation only R4. So R4 is what? 0 minus 0, 0, 1 minus 1, that is 0, and 1 minus 1, this becomes 0, and 0 minus 0, that become 0. Now Come to the third row, search the non-zero element. The first non-zero element is this one, and this is a leading element of the third row, and the below entry should be 0. It is already 0. Now the property, or say the by the definition of Echelon form, it fulfill the property. So we can say this is a Echelon form of given matrix A. Now what is the rank of that matrix? So rank of the matrix is what? The Now check the number of non-zero rows. So here we have 1, 2, 3. 3 non-zero rows. So we can say the rank of the matrix is 3. So because one row is what? Is completely 0. We have only 3 non-zero rows in the Echelon form of that matrix. So this is a rank of a matrix is what? 3. Take other example. Determine the rank of a given matrix. We have a matrix of order 3 cross 4. The given matrix of order 3 cross 4. We have 3 rows and 4 columns. So we apply Echelon row Echelon form method. So first we convert that matrix into the row Echelon form. So this is a given matrix. Here we search the first non-zero element of the first row, that is 1. If it is not 1, to make it 1, and the below entry should be 0. So we apply the operation on R2 minus 3 time of R3, and on R3 we apply R3 minus R1. So the matrix reduce 1 3 4 3 0 0 0 0 0 0 0 minus 2. Now we check the second non-zero element of second row. All the element of that row is 0. And now the come to the third row, search the non-zero element. So non-zero element is minus 2, and there is no below entry. Now we check this is the Echelon form or not. So we was discussed in the previous, this is the Echelon form of a matrix or not. So for that we know this is not Echelon form right now. So if it is be Echelon form, so uh, the first row is 1 3 4 3, and the first element all the entry is 0. And the second property, which is a definition of Echelon form, which is what? All the row consisting only zeros are at the bottom. So there is one 0, that is row 2. So we interchange that row with row 3. We apply the operation R2 interchange with R3. So we get this matrix, and this is a Echelon form because there is two definition of the Echelon form, that is the leading element of all non-zero rows is always strictly to the right of the leading element of row above, and the second word, all the row consisting only zeros are at the bottom. So this is the Echelon form. The matrix is reduced into Echelon form. Now we check the number of non-zero, how many number of non-zero rows. So there is only 1 and 2 are non-zero rows, and one row is completely 0, this one. So we can say the rank of the matrix is what? Is 2. Now the rank by the normal form, or we say canonical form. So what is the normal form of a matrix? So first we have to discuss the normal form of a matrix. The normal form of a matrix A of order, suppose m cross n, of a rank R is one of the form this IR, IR0, IR0, and IR0, 0, 0. So these four form are called normal form. Here IR is what? Is an identity matrix of order R. So by the elementary operation, the given matrix of reduce into any one of the normal form, and the rank of the matrix A is R. If we reduce the matrix into the identity of the order R, then we say the rank of the matrix is R. Now we take an example to reduce the matrix A into the canonical or normal form and hence find its rank. So first we convert the matrix into the normal form. The given matrix is 3 cross 4 order. So when we convert the matrix into the canonical form, you have to remember you can apply row and column both operations. So we follow. We search the first non-zero element of first row and first column. So this is the non-zero element of first row and first column. So if it is not 1, so make it 1. This is called the leading element, and the below entry or the leading element make it 0, and also the right hand side entry also make it 0. So follow that step. So by the help of that element, these element make 0. So we apply the operation on column and row, but don't apply the operation simultaneously. We apply the operation one by one. First we apply the operation on columns, then we apply the operation on row. So the first operation we apply C2 minus 2 C1, and on C3 minus C1. So the matrix become 1 minus 2 1. The first column same. This is 0. This is 4 minus 2 time of 2, that is plus 4. 4 plus 4 8. This become minus 2. Now the third column 0 5 1 0. Third column 0 and minus 8. So now the now the search. Now by the help of that leading element, the below entry is 0, so we apply the operation on R2 and R3. So R2 plus 2 time of R1, R3 minus R1. So the matrix reduce 1 0 0 0, and this has become 0. This is 8 5 0. That element becomes 0 minus 2 1 minus 8. Now search the non-zero element of second row, that is 8. Now this become the leading element. The below entry makes 0 and the right hand side element also makes 0. So first that element should be 1. For that we apply the operation on C2 column 2, that is 1 by 8 C2. The matrix become 1 0 0 0. This become 1. This become 1 by 4 with negative sign. 0 5 1 0 0 minus 8. Now this element is a leading element, so the below entry makes 0 or the right hand side element should be 0. For that first we apply the operation on column. So apply the operation on C3 minus 5 time of C2. If we apply the operation on 1, so C3 minus 5 time of C2. So what will happen? 1 0 0. This becomes 0 1. This is minus 1 by 4, and this is 0 0, and this is what? This become 9 by 4, and the last column is same. Then we apply the operation on R3. 4 time of R3, so it become 1 0 0 0 0 1 0 0 0. This is minus 1 9 and minus 32. Now By the help of that element, you make this 0. So we apply the operation on R3 plus R2. So it becomes 1 0 0 0 0 1 0 0 0 0 9 and minus 32. Now search the non-zero element of third row, that is 9. So make that element is leading element, so make it 1, and by the help of that one, there is no below entry, but on the right hand side, that is minus 32, make that 0. So we apply the operation on C3, 1 by 9 C3, the matrix 1 0 0 0 1 0 0 0 1 and 0 0. This is minus 32. Now by the help of that element 1, you make that right hand side element 0 by apply the operation C4 plus 32 time of C3. So the matrix become 1 0 0 0 0 1 0 0 0 0 1 0. Now what we see, this matrix is what? This is a what? Identity matrix. So it become I3 0, right? So we can say after reducing the given matrix, when we convert into a normal form, so the normal form of that matrix is what? I3. So we can say the rank of the matrix A is what? 3. The number of non-zero rows in I3. You also can say the number of non-zero rows in I3. So this is the way to use the normal form and find the rank. Here we can reduce so many steps, but I'm explaining you. So there are a lot of steps we can reduce on, and many number of ways you can apply the operation to reduce or to convert the matrix into the normal form. Okay student, I explain you about the rank by the three methods, that is Echelon form, minor order and normal form. You can use any one of the method to solve the problem. Please do some practice for unsolved problem at your home. More you practice, more you learn. Thank you.